In this course, you'll learn all about using HTTP client and HTTP client factory to integrate with an API. As long as you're running on a platform that supports .NET Standard 2.0, what you'll learn in this course applies to that platform. DTO classes can be shared between client and API by using linked files or a shared assembly approach. But we're mimicking a situation where we don't have control over the API, nor knowing what technology it was built. Therefore, we use code generation via NSwag Studio to generate our DTO classes. This requires the API to have an open API specification of itself, for example via Swagger. When we use HTTP client, each request travels through a series of message handlers and each response travels back through them, the other way around. These handlers thus form a pipeline of handlers, and each handler can choose to pass the request through to the next one, or cancel it. And that's what's called the delegating handler pipeline. It allows for some pretty cool fine-grained scenarios by creating custom handlers, as we'll do later on in the course. Important to know for now is that the default last handler in the pipeline is the HTTP client handler, which is responsible for actually sending the request. Speaking of sending requests, it's about time we started doing that. In the next module, we'll dive into tackling CRUD operations. Let's start at the beginning by implementing create, read, update, and delete functionality. I'm Kevin, and I'll guide you through this module. So, in this module, we'll learn how to integrate with an API. In other words, basic functionality. We'll start with getting resources, but we'll also learn how to create, update, and delete a resource. We'll soon see that there's multiple ways to do that, from using shortcuts to directly manipulating the request and headers. So, we'll cover different approaches and learn what the best practice is. Along the way, we'll dive into content negotiation. We'll learn why it's important and how we can work with it. Let's start with getting a resource. In this demo, we'll learn how to use HTTP client to get a resource. We're looking at the CRUD service, the first implementation of the I-integration service interface we'll be working with. The run method is automatically executed when we start up the app. Let's create an HTTP client instance. HTTP client is defined in the system.net.http namespace. So let's add a using statement by pressing enter. For now, we'll store this in a private static field. Now let's have a look at HTTP client. Let's add a constructor for that. There's a set of options we can set here, like base address, the default request headers, and the timeout value. These configuration values will be used by the HTTP client instance for all requests. Let's start with the basics and set the base address to the base address of our API. And let's say we wanted to time out after 30 seconds. For that, we set the timeout property to a new time span of 30 seconds. We're covering additional configuration later on. We're going to get a resource, so let's add a new method for that. Let's name it getResource. HTTP client calls are async, so we have it return a task and mark it with the async modifier. The async modifier ensures we can use a wait statement inside of this method. From here we can access our static HTTP client instance. A small word of caution though, HTTP client, via the underlying handler, implements high-disposable. So that makes it tempting to write code along the lines of this, with a using statement, so the instance is disposed of after the request. But this is not a good practice, and it should be avoided. We will dive into the reasoning behind this in the module on improving HTTP client instance management later on in this course. For now, just remember that HTTP client is, and always has been, intended to be long-lived and reused. And that's why we are storing it in a static field. So let's get rid of this bad code. To get a resource, say our movies, we can use the getAsync method. We pass through API/movies, as that's the URI of our resource when it's combined with the base address. The getAsync call returns a task with an HTTP response message as the type of the resulting object. And that matches what we learned in the previous module. There's quite a few overloads for getAsync as well. We can pass through the request URI as a URI or as a string. We can pass through something named HTTP completion mode. We can pass through a cancellation token and so on. So there's a lot of combinations possible, and we will dive into all of this. But for now, we're quite okay with just passing through API/movies. So with this call, we should get a response and do something with it. But before we continue with the response, we must know whether it was successful, i.e. whether it returned the level 200 status code, like a 200 OK or 201 created. If we get back something along the lines of a 500 internal server error, we can't just continue. There's a full module on handling faults and errors, but for now, we'll just call response.ensure status code. This will throw an exception if the response wasn't successful. Let's put a breakpoint here, and let's make sure getResource is called when the run method is executed. Let's build and run. And there we go, we hit our breakpoint. And if we look at the response, we see we got back a 200 OK. Yet, we cannot seem to get the actual content. You'd expect to see a list of movies, right? Let's continue. So we have our response now. How do we work with this? On the response message, we can find a content property of type HTTP content. But that doesn't directly contain the list of movies as text we'd expect from our API. The data we get back from an API can be regular text, but it can also be part of a message that's still being streamed, or a multi-part message. HTTP content is an abstract base class that allows support for all of these. But that also means we must read the data from the HTTP content object. For that, methods exist on that content object, like read_as_stream_async and read_as_byte_async. In our case, we know we're going to get back a string. So we can call read_as_string_async. As it's an async method, we await this and we store the resulting content in a content variable. That content variable is of type string. Let's have a look at what that gives. We hit our breakpoint, so far so good. And if we look at the content variable, we see that we got back a JSON representation of our movie list. So far so good. We can now use JSON.NET to deserialize this into movie objects. We do that by calling deserializeObject on JSON convert. That's defined in the Newtonsoft.json namespace, so let's add a using statement by pressing enter. We pass through what we want to deserialize the JSON string to, which is an IEnumerable of movie. And movie, well, that's defined in our movies.client.models namespace. We got that from when we generated the DTOs previously. Lastly, we pass through the content as a parameter. Let's give this another try. We hit our breakpoint, and there we go. We now have a list of 7 movies. So far, so good. But why did we get back JSON? Well, we got that back because it just happens to be the API's default, i.e. the default media type is application JSON. But not all APIs default to JSON. In fact, supporting different formats isn't that uncommon. The API we're working with supports both XML and JSON. So let's switch its default for a minute. For that, we open the startup class at API level. And we uncomment that code here. Let's comment out this one. With this statement, we're adding the XML serializer output formatter and input formatter as the first one in the list of output formatters and input formatters. And that defines the default. Let's run our code again. And this time we don't hit our breakpoint, but instead we're crashing on deserialization. And that makes sense. We, the consumers of the API that supports different data formats, just assumed it would default to JSON. Instead of assuming this, In HTTP, it's best practice to explicitly ask for the format we want to work with. Doing so improves the stability and reliability of an application. Let's learn how to do that by looking at HTTP headers. When we checked out my website with Chrome's DevTools in the previous module, we saw that the request sent by the browser contained a set of headers. And so did the response sent back from the server. These HTTP headers allow passing additional information with each request or response. Such a header consists of the header name, which is case insensitive, followed by a colon and then by its value. If multiple values, or strictly speaking parts of a value, can be set, use a comma to separate them. The headers of a request contain more information on the resource to be fetched, or about the client itself. It's the responsibility of the client, be it the browser or our HTTP client instance, to provide these. We'll encounter a few of these throughout the course, but a common request header we'll immediately use in the next demo is accept. This tells the server the media type the client is willing to accept. For example, JSON, or preferably JSON, and then HTML. The headers of a response then contain information on the generated response or server. These are thus generated by the API, or an in-between mechanism, and tell the client, for example, how to deserialize the response. That's what the content type header is for. It provides the media type of the response body, for example, JSON. A lot of headers are optional, yet it's important to be as strict as possible to improve the reliability of our requests. For example, that accept header we just mentioned is often not set, but it is an obligatory header in RESTful systems. It improves reliability. If we would have set a request header in the previous demo, our application wouldn't have crashed. That mechanism is called content negotiation. Any resource, like our list of movies, can have different representations. For example, the API can provide our movie list with a JSON representation, but also with an XML representation. It's still the same resource, API/movies, but the representation is different. Content negotiation allows the client to tell the API which representation is best suited for it by passing the media type through the accept header. If it passes through an accept header with value application.json, the API must return a JSON representation. If the value is application.xml, the XML representation must be returned. It's thus the mechanism that is used for serving different representations of a resource at the same URI. Accept is one of the headers used in content negotiation. Others are accept encoding, accept language, and accept charset. Let's check this out with a demo.